Sorry, everyone. So again, my name is McNamee. As I said, I'm a designer living in Berlin. And I used to be a software engineer and studied design, and now I do design practice and kind of live somewhere between sort of software development and graphic design. So as part of that, there's been kind of a new generation of tools that exist, like processing, open frameworks, whatever, which are basically software systems for designers or for visual programmers. And so today I'm going to talk to you about Flask. So Flask is a multimedia tool basically for graphics programmers. And basically, in the end, the function of Flask is to enable you to make images. Whether that ends up being sort of like charts, graphics, art, film, and unfortunately, I think when I give a talk like this, there's a lot of people who are excited, but really I think Flask has always been focused on people who actually are kind of doing this as their profession. I'm a designer and I work with a lot of other designers. We've sort of built a tool for us as designers to better perform our design work. And so it's not for building applications, it's more for doing basically visual design work. And in a way, I would say that it's an experiment. It was looking at, sort of at the time, what technologies were really interesting, and if we could build something really simple that just brought together some modern technologies and allowed us to sort of make new types of images, for example. So basically, in the end, what it actually is basically a set of graphics APIs, functionality, that you can program in JavaScript. So these are the core components, I would say, of Flask. I'll just quickly go sort of one by one to tell you sort of what the system's composed of, and then I'll spend the rest of the talk giving you lots of example projects, these things that have been built into the system. So basically, its core is V8. And actually, at the time that I wrote Flask about 3 years ago, I was working at Google on the Chrome and a little bit on V8 teams. And I'm not really a JavaScript programmer, that wasn't my background. But I was more just noticing sort of the momentum that JavaScript had, both in terms of the performance of the runtime, the libraries, the users. And basically, it was clear that it was a really good sort of platform to build something on. And actually, when I started Flask, Node didn't exist yet. And then Node came around and also came with a lot of momentum. So that really kind of fit really well together. So the second piece is actually also quite important, which is Cocoa. Flask is an OS X only system, and this is basically the interface with the platform for windowing, keyboard handling, mouse, multiple displays, full screen, all of this kind of stuff is done with Cocoa. Additionally, Skia is another quite important piece of the system, and that is it's comparable to, say, Cairo, basically doing 2D vector graphics. And this was another Google technology, and it's used in Android, for example. It's used in Chrome for rendering a canvas tag. And it's very fast. It was originally designed for mobile devices. And it also gives you like a lot of control, which is really important actually as a designer. For example, if you're trying to do something in the browser, there's APIs to draw a circle and fill it, whatever, but you don't really have detailed control over what type of anti-aliasing, how things fall. And this actually ends up being quite important that you really have very detailed control over how things are rendered. It also supports things like PDF generation, and I'll show you kind of examples of all of this stuff. Next is OpenGL, and I would say that actually how Flask started was just wanting to do V8 and OpenGL. So I think that OpenGL is basically one of the most important pieces. And it was only sort of in the last few years that, I don't know if people know a bit about graphics programming, but basically OpenGL kind of shifted to be a totally programmable pipeline. and now basically you write everything in shaders, and these run on the graphics cards completely. So it basically eliminated the need for a powerful CPU or a powerful language. So graphics used to be all written in C, C++, and very worried about sort of the efficiency of the graphics routine. Now basically all of this has moved to the GPU, and it means you can use a language like JavaScript, which is not that fast for manipulating pixels and all that stuff, but it doesn't matter anymore, because actually it's more convenient, better anyway to do it on the GPU. And now you can use a really easy language like JavaScript just to sort of manage everything that's going on. Okay. And also it fits in quite well, because actually, if you know a bit about OpenGL, it's actually a client-server architecture. So it's really almost like your graphics card is a server, and JavaScript's a client. You're basically just sending messages back and forth. So you package up some data, you send it to the GPU, you package up some code, you send it to the GPU. So it's really like front-end, back-end. So you actually have this completely separate component now, which is the GPU, and OpenGL is how you access that. And in terms of Flask, we implement basically a WebGL interface, so it's more or less the same as the browser WebGL. Another thing that becomes really interesting is this thing called Siphon, which I can speak a little bit about later, but basically allows you to share images between processes on OS X. This free image, which is basically used for loading in lots of types of image file formats, and also reading and writing basically images. There's MIDI, which might seem a bit funny to people because it's a very old protocol, sort of has a weird reputation, but actually there's lots and lots of devices and interesting things that support MIDI, both like within a system and physical interfaces. So it turns out actually, like in a lot of cases, MIDI has actually been sort of the right messaging mechanism to do something really simple. So this is pretty nice. And of course Node, which is basically within Flask, it's used as sort of the POSIX API, so reading files, doing network, any of this kind of stuff. And any Node application will run inside of Flask. So anything on NPM will work. Basically, any Node-related stuff will work the same in Flask, except you have the addition of all of this other functionality, all of this other graphics. So when I say that, you might ask why Flask isn't just, for example, another Node module. So that instead of having Node inside Flask, you basically would have Flask inside Node. And it basically turns out that there's a bunch of technical reasons about the architecture of UI, messaging, and all this stuff that requires Flask to sort of be the main application, and Node is one piece of that. And I really believe that you effectively can't do this just as a Node module if you want to handle all of the messaging correctly between mouse and keyboard events and all this kind of stuff. So, moving on. I think this, briefly discuss a bit of philosophy, and then we'll go into all of the examples. But I think, at least if you've looked at sort of how people have done graphics programming in the last 10 years, it's always sort of been like a very thick application, a very, nothing's kind of composed of pieces. Everything is like a big monolithic C++, Java, whatever application. And everything's sort of an environment. So for example, using processing in Java, if you want to do anything, you have to figure out how to bring it into this world. Like, how do I bring it into the processing world? How do I bring it into the C++ world? And I think we've seen in a lot of different programming tasks that actually it's much nicer to sort of break your problem into pieces, use maybe client-server or just messaging architectures, and basically not create these big mega systems, but instead create many of these small systems and have them communicate with each other. And that's why I consider Flask not an environment, like a lot of the other systems, but basically a small tool that can fit in a lot of different places. And just to quickly continue on that, basically this is a website for Open Frameworks, which is basically another graphics programming framework. And basically you can see from the side of the scroll bar, this is the list of plugins for Open Frameworks. So basically if you want to do anything inside of Open Frameworks, you need to somehow bring it into the Open Frameworks world. So you just look, like for example, there's all of these wrappers. So like, if you want to do some DMX communication, someone has to write OFX DMX, which is a wrapper basically just to expose this functionality into Open Frameworks. And I think the biggest thing Flask does differently is take the philosophy that we shouldn't try to create this big system and try to drag everything inside of Flask, but instead to sort of support the modern paradigm of messaging and JSON and networking to allow you to sort of communicate between these pieces instead of just creating like a mega system. And of course, like all good design philosophy, less is more. So Flask is 8,000 lines of code, and I don't really think it will grow that much. And the idea was kind of to see what's the minimum system, sort of just also like the node philosophy. What can we build that we really think is kind of, you know, the most for the least, and then see what we can do from there. So I know everyone wants to see a little bit of code. I won't concentrate this talk on examples of how to use Flask. Can you see this at all, actually? I can't really see the projection. All right.
Switch the mode, make it white on black, or black on white.
It's not that important. It was just to show, basically, to give you an idea of sort of the syntax and the APIs, but I don't really think that's the point of this talk anyway. So you can obviously download Flask and look at some examples to get an idea for how it's usually structured. But now I will go ahead and jump into basically the rest of the talk will be a showcase of projects that Flask has somehow been involved in, and I'll basically discuss, you know, how the project worked, what Flask did, why it was a good tool for the job. We have sound. Sorry, I can't talk and have the sound work at the same time, unfortunately. So basically, with this project, it was a project I did for Native Instruments as a sort of like a product video for a synthesizer they were working on. And the idea was basically to figure out how to visualize basically the internal operations of the synthesizer and to make sort of a music video from it. So basically what we did is there was a sound designer who designed the actual sort of dubstep track, and then basically we dumped a lot of data from inside of the synthesizer, basically what all of the internal sort of oscillators and stuff were doing like that, and then the goal was to visualize it. And basically Flask was used as a prototyping tool, basically to consume all of this data and try a lot of different styles and visualizations of basically the audio. And then in the end, I mean, in a lot of these projects, you won't do something just in code. You still end up using professional sort of 3D software, professional post-production. So basically, Flask generated all of the animation and the geometry, and then it was brought into 3D software at the end to do the final rendering and like all of the... Can you see the screen all right? I guess it's not so great because of the sun. So in this case, I mean, Flask was used basically as 3D software to quickly kind of visualize a bunch of data, to make a bunch of prototypes, and then in the end to generate the actual animation and the 3D data to go into 3D software and generate the final figure. It's a bit dark, I hope you can see something. This is a project done by a guy called Ryan Alexander in San Francisco. And basically, he's using Flask as a VJing tool. So, I mean, this basically he's sort of doing real-time graphics, particle simulations, etc., alongside of electronic musician. So in this case, it would be similar to something like Chord Composer, something like that. Basically doing real-time graphics. And I think the reason to kind of show that example is to show basically what I was saying before about the OpenGL. Even using JavaScript as the only programming language, you can still do very, very complicated 3D particle, all of these graphics, because all of this work now is done on GPU. So I don't really feel like these languages anymore restrict what's possible to do in the graphics domain. So now it's kind of up to you which programming language you find comfortable, what you want to use for which reason, and performance has become less of a concentration. And at least in my opinion, like most things now are possible in Flask, even using JavaScript as as the main language. I realize it's quite difficult to see, if at all possible. Well, I can just speak about the project. Basically, this was an installation that was done with a cellist, who's you can't see, but who's in the picture. And basically, it was a system of lights and lamps, and it was sound reactive. So there was a feed, a live feed from the cellist. And then there was a system to analyze all of the sound, the frequency, the attack, different aspects. And then Flask was used basically to respond to all of the musical and sound properties, and then to generate basically visuals that were used to control these lamps. So basically there's a physical hardware system to be able to dim all of the lamps. And then Flask is also responsible for both generating the visuals and for sending the network signals basically to dim all of the lamps in real time. So this was a performance done in London, and there was basically different systems composed of the cellist for each track. As he played, the lamps sort of had a different reaction, but everything was driven from the audio. And in this case, hopefully you can see this a little bit better, Flask was also used to build a sort of pre-visualization tool. So basically what you can see here, but basically you can just play a soundtrack, and then on the left you have sort of a 3D model of what the stage will look like with all of the lamps, and then you basically visualize the same thing that will happen in the performance. So this basically is a tool to allow you to create basically the content, in this case, in order to create the algorithms that will be responding to the audio before you actually go and have a stage set up. And basically, in order to understand if things feel right, if this is actually creating some kind of mood, you can't just look at sort of like some pixels across the screen. You really have to have some kind of 3D model, some kind of idea of what the environment will be like. So in this case, Flask was used to do all of the OpenGL graphics, whatever, to build basically the 3D scene, and also to do all the lighting, all the lamps, basically to simulate what the final performance will be like. And in the end, the same application is the same application that actually controls the lights. So basically, when you're doing the performance, you can see it on the screen, and you can look at the performance, and basically it's exactly the same thing. And this is a very important thing for design practice, because basically building these simulators, you're doing anything sort of spatial or involving the real world, you want to be able to have some kind of pre-visualization of what things will look like, because it's really the only way to design content. This is another project done by Ryan Alexander, which is basically using a pen plotter to create these images. So it's a marker inside of a plotter, and you use Flask basically to generate all of the paths that the marker follows. So I can just play the video again, maybe understand it's a bit hard to see. So in this case, Flask was used as the system to design basically, it's almost an animation, but yeah, basically to design all of the vector hardware that runs on the plot. So in this case, it's basically using all of Flask's vector APIs, also functionality in terms of there's some basic math routines, all this kind of stuff inside Flask, and then it's able to export a PDF and send it to again, I realize, I apologize, it's hard to see. Basically, this was an installation I worked on with a sound designer called Trevor Jackson. And basically, it was an installation for Lexus in Los Angeles, where they basically just put two cars in a parking lot, filled them up with smoke, and then put lights inside. And it was completely sort of incognito, so every 10 minutes, basically, there was a sound and light performance. And there was just these two cars sitting in an parking lot. So people would be walking through, all of a sudden these cars would sort of come alive. And it was very important for this project that sort of the sound design and the lights are very closely coordinated. So actually, in this case, he proposed all of the sound design, and then basically used the same MIDI composition to drive the lights. And so what I did was use Flask basically to build what you see here, which is again sort of like the last project, it's a visualizer. So you have two 3D models of the cars, and the lights sort of react in the same way. Basically what this application is doing is it's reading in the MIDI signals from the musician's sequence setup, and it's translating these into like lights, basically light curves. So you get basically a note message, and you decide you want to make sort of, you know, a color or hue change, you want to make some kind of like flash, how strong you want, and sort of attack decay and all of these kind of parameters. And basically, this also works so that it was a tool that was also given to the musician, basically, so he could also create the sound design, knowing what the lights will look like. And it's actually kind of interesting because then he actually changes the sound basically to decide how he wants also the cars to look again. So in this way, it's sort of a dialogue also. It's not just a sound designer who does it, and then we do lights through it. It's also the simulation of what the lights will do also ends up changing what the actual sound is created. And here's just some more footage of, I'm not sure how well you can see it, but this is basically just some test footage of the two cars with the lights inside. And basically Flask is just running on a laptop responding to MIDI, and Flask was also used during the real event to run the cars. And I think, at least in the stuff we do, it tends to be very low budget and very quick, so it's important to have basically systems that work in real time, so that things can be changed up until the minute the project happens. And also systems that are built in these kind of components, where someone you can separate things. So a sound designer who understands what he's doing, he understands MIDI, and I can come and I can have my piece, and not really force him to change how he works, but to sort of to connect it. And also then Flask has to be able to support, to speak the right protocols to run the lights. And this ends up being quite simple, just with nodes and nothing. And just to give you again an example, I guess it's a bit hard to see also, but this is the simulator. So this is Ableton Live running some example sequences. And you can see these are the cars. So just on a desktop computer, you can just sort of start sequencing music, and you can have you can see what the cars will be doing in the final performance. This is a bit of a different project. This is something that a friend of mine, Marcin, did for Nike in Los Angeles. And basically, Nike had launched this new kind of shoe where it measures how high you jump. And they wanted to make an installation to sort of highlight this. So they had a basketball court on the top of a building in Los Angeles, and then a giant LED wall behind. And they wanted to have the LED wall basically react as people dumped and made baskets. So here's some video footage. Basically, it's hard to see, but there's a net in the middle, and this is the LED wall. And then there's a tracking system that was built basically to be able to detect when someone dumps. So you'll be able to see in a second. Yeah, you can't really see very well on the projector, but basically someone came and dumped, and then you have these visuals reacting to how high they jump, how they dump. And this is a good example of sort of also having to design a system that's going to work with a lot of other components. It needs to be able to work with an LED wall, it needs to be able to work with other tracking equipment you're using for the dunking. And I think this is why it's so important to break away from this older model I was talking about, having everything inside, and instead just basically try to speak a lot of protocols, and try to figure out, okay, how do we build a tracking system that can send some networking data to our system so we generate the visuals, and we can send this to the LED wall. So in this case, Flask, you can see, is running on this bottom computer. And it's driving all of the visuals on the LED wall. And so you have some screenshots, basically, just to kind of show you like a visualization of the wall, and all of the sort of parameters at runtime. And here you see this is the tracking system, and it was actually built outside of Flask. So basically you look and you say, okay, actually, there's these different technologies we can use. Okay, this is the best thing we can do. And now instead of figuring out how to do that in class, let's just look at what's the best way to solve this problem. Maybe it's using some proprietary SDK from the camera company, maybe whatever. So we just build this tracking system, and then in the end, we just need to send a message saying, okay, there's a jump, or the jump is high. And then these messages just sent over the network to Flask, and then Flask can respond to all of the issues. And this also is quite nice because, for example, if your camera tracking system breaks, it doesn't break the entire LED wall. So now your UI system, the thing generating the graphics can just realize, okay, I'm not anymore connected to the camera system, I'm going to fall into a state where I'm just Nike Plus, I'm doing some animation or something. And this is really important because these projects are usually one-time things. You don't really have a lot of chance to prepare. You need to make sure that you build things kind of in a robust way that have some kind of fallback, so that you're not doing a press event from Nike and all of a sudden, yeah, it just freezes. It's difficult to see. This is a project that we did for Wikipedia for the 10th anniversary in London. And basically what happened is they had an anniversary party and we built this installation with these printers hanging overhead. And as people made edits to Wikipedia, it printed a little ticket that fell down. And the ticket looked something like this. So it said, on Thursday at 3:47, the user of this contributed to this article. And basically this is the description of that article. So as you walked into the lobby of the anniversary party, there was basically these snowflakes printing about 1 every 2 seconds. These tickets falling down, basically all of the activity that was the whole world contributing to Wikipedia. And in this case, Flask was basically used Node was used to, as part of Flask, was used to basically scrape all of the activity from Wikipedia. So basically going, this is a special page where you can see all of the edits that are happening, summarizing the articles. And in this case, it's a good example of Flask not trying to solve all problems, because when you come to actually creating these tickets, Wikipedia content is full of multiple languages, Arabic, right to left, and trying to build a whole text system is not a good idea. Actually, when you look at the text systems, a lot of other frameworks, they have a lot of problems. So basically, it was doing everything in Flask and then building a very small Objective-C program that would just use for graphics directly. And then generating these PDFs and sending them to the printers. This was another installation in Copenhagen. And basically, it's pictures from all around Copenhagen built into these sort of like pyramids, like the games you used to play when you were a kid. And basically the idea is that the image is warped so that it only looks correctly when it's looked directly on. So basically it's a flat image that's made into a pyramid. The perspective is only correct when you're looking at the pyramid exactly in the front, so that it's square. This was a project by Martin and Dime. And basically Flask was used for all of the simulation and the 3D warping, and also all of the preparation for printing and laser cutting. So basically, you can see here some screenshots kind of the debug system, and here's sort of a quick screencast basically of the tools Martin had built. Basically, people load all the images in, create the structure will be, and just sort of visualize what the final sort of object in this case will be. And then after having sort of the 3D simulation, then you actually need to prepare it for printing and laser cutting, and in which case it uses Flask again to generate a PDF template of all of those images with the images warped, and also all of the 3D cutting profiles. So in this case, Flask is used to generate a PDF that's just sent to a laser cutter, actually. So first it's printed and then everything's laser cut to create the platform shapes. And these are just some pictures of the final artwork, if you will. This is the laser cutter cutting. This is probably the earliest project that was ever, that Flask was ever used for. And basically it was a data visualization project for the New York Times. And what had happened, it was just after the World Cup, and there's a company who basically writes software for the actual teams, so for Spain and the Netherlands. And They basically, I think they just do it by hand and with lots of cameras. They track super detailed information about every single play in the game. So at this point on the field, this player at this millisecond made a pass, made a shot, or whatever. And this company basically considered this data worthless once the World Cup was over. So we're just given basically a big XML dump of all this data, and we did a data visualization project on it. So basically, Flask was used to read in all this data, and basically to generate, I'm not sure if you can see this at all, but to generate basically these sort of heat map graphics. They look a bit like a weather map. So you can basically look at stuff like, how does this team pass? How does this team play? Where did this team shoot from? And so basically we looked at thousands and thousands of events from every game across the whole World Cup, and could say like, this is how this player shoots. This is where he passes from. He kind of plays to the left and kind of plays to the right. And this was done for the Times in London, and was printed in a special about basically analysis of the teams. How are we on time, by the way? Yeah, it's up to you. It's fine. Yeah, just let me know. This is another data visualization project, which we can't see at all. I will try to see if there's any photo. I will skip it. Okay, you can see this in a little bit. This is another project, also similar data visualization that Martin did for Maersk, the shipping company. So Maersk is the largest logistics shipping company in the world. The one with all the green containers with the Maersk logo. And basically, he got GPS data for every single shipment. And so this is a visualization of basically all of the traffic, all of the ships moving through Maersk. And also built a 3D visualization. So you can see these are basically all of the ships moving across the ocean, and all of the routes. This is a bit of a more zoom. I will talk quickly about a few last things just to explain also some of the capabilities. This is just a quick sort of example. Basically what this shows is just an audio reactive sound visualization. So I'm playing a track by Mount Kimby, and then just generating some graphics in response. But what you can see here is Siphon. So basically, if you make something in Flask, you can just very easily share any other application that supports Siphon. So in this case, this is a VJing application called Resolute. So Flask is running, and Resolute is able basically to see all of the graphics that Flask makes. And in this case, now you can use any of the features of this VJ software. You can use filters, you can do any effects, or you can integrate it with all of these other aspects. And this is really nice because it no longer means that Flask needs to become a plugin to some kind of software. It just needs to basically speak this Siphon protocol. And now you can basically stream data, video in both directions effectively. So Flask can take in a video feed, it can do some effect something, and pipe it back out again. So basically you have sort of support for pipes for real-time video graphics. And this all happens on the GPUs. It's actually really efficient. And I think this is a really great example of how you can break away from the old model of doing things and start kind of composing all of these different... The goal is not to rewrite a VJ tool. If someone wants a VJ, Flask is not trying to be a VJ tool, but it's at least trying to allow you to integrate with sort of the other world of graphics software. Yeah, I think I'll stop there. So hopefully, I didn't concentrate too much on the technical elements of Flask. I think if you're interested in it, you can take a look and understand a lot better about how it's built. But basically, the thesis that I'd have you try to understand is kind of, because of all of these modern technologies, VA, JavaScript, whatever, basically able to bring a few very simple ideas together. And still, as you hopefully saw from projects, be able to do a lot of different kind of projects in very short time spans. And I think JavaScript is also sort of a reason for this, is we can change things really quickly, we can react really quickly. Basically creating a very small programming environment to do experimental graphics, to do installations, and in general to kind of do design work. So thank you very much. Hopefully you understood or saw something from this, and enjoy lunch.